Welcome back to part 4 on this section on polar coordinates. We're going to look at example 5 now, where we need to express the following equations in polar coordinates. So the first one we have here is 3x plus 2y equals 4. I'm going to substitute r cosine of theta in for the x and r sine of theta in for the y. And then I'll just rewrite everything else next to it. So that will give me 3r cosine of theta plus 2r sine theta equals 4. From here, I'm going to factor out the r, which will give me r times 3 cosine of theta plus 2 sine of theta equals 4. And then if I want to find or isolate r, I will divide both sides of my equation by 3 cosine of theta plus 2 sine of theta. This gives me r is equal to 4 divided by the quantity 3 cosine of theta plus 2 sine of theta. Here we have y squared equals 4x. So I'm going to replace the y with r sine of theta and square it. On the right side I have 4x, and I'm going to replace the x with r cosine theta. This gives me r squared sine squared theta equals 4r cosine theta. Since I'm trying to solve for r, I'm going to divide both sides of my equation by r. And then I will have r sine squared theta is equal to 4 cosine theta, because the r is divided out on the right. Then, if I divide both sides of my equation by sine squared theta, I will have r is equal to 4 cosine theta, and then I'm going to write this in a kind of a weird way. I'm going to write this as 1 over sine theta. And also, under the cosine theta, I'm going to write another sine theta. Do you see how when I write it this way, I have a cosine theta over sine theta times a 1 over sine theta? This is convenient because then I can write this as two more squared away trig functions. So I'll have 4 times cotangent of theta times sine of theta. This just looks better and it represents the radius. On this next example, we have x equals 2. So I will go ahead and replace the x with r cosine theta equals 2. Then I will solve for r by dividing both sides by cosine theta. And I get r is equal to 2 divided by cosine of theta. I could also write this as r is equal to 2, and 1 over cosine is just secant. So I could write this as 2 secant theta. On this last example, we have x squared plus y squared equals 9. Now, I know that x squared plus y squared is just equal to r squared. I could certainly replace the x squared and the y squared with r cosine theta, quantity squared, plus y squared, replace that with r squared sine squared theta. But then I would just factor out my r squared, and I'd be left with cosine squared theta plus sine squared theta, and that's equal to 1. So it's easier just to remember the formula that we had before, r squared equals x squared plus y squared. and just replace the x squared plus y squared with r squared, and that's equal to 9. Therefore, r is equal to plus or minus 3.